A few words about session. This tutorial is about Python data visualization to accelerate data and business understanding. If I saw the name of my talk, I would think, yet another talk about data visualization. If you open your browser and search for data visualization, the search engine will generate various types of information about this topic. Also here on DataFest, there are many influential talks about this field. So I think on the one hand, it's really hard to say something new. But on the other hand, I think for people, especially for beginners, it's really hard to find their unique way of learning data visualization because of this variety and the verbosity of the content on the internet. I will try to give you high level, although practical overview of this very interesting topic from my as a data scientist's perspective. And I think this workshop will be useful for both for beginners and also for intermediate level people. As I mentioned, these topics will be shown from my point of view. So some statements I will make during this session might be opinionated, if not indicated otherwise. Here you see a high-level table of content. Our session consists of two main parts, theoretical and practical. In the first part, we will discuss why is it important to make data visualizations, how to do that, and what are the tools we can use effectively. The second part is practical one. We'll focus on visualization library called Bokeh, which is mainly built for Python programming language. We'll utilize the library together to build our first interactive graphs. What I want to ask you is that I want this workshop, especially the second part, to be as interactive as possible. So let's start from part one, which is the theoretical one. First question is, first of all, let's ask the question, why data visualization matters? We all know that it needs some effort to make visualizations. So it's legitimate to ask this question, right? Is it worth doing at all? In order to answer these questions, let's say once again, what is data visualization? Based on definition of Wikipedia, data visualization refers to the techniques used to communicate data or information by encoding it as visual objects, like points, lines, or bars contained in graphics. But what is opposite of visualization? The opposite should be no visualization, right? And no visualization should be the act of leaving data in a raw form. But what is raw form? Everything that we see on our devices is graphical representations of information that is written on the hard drive. So it's really hard to say what is the raw form of the data. But let's assume data is given in raw form if it's not intentionally transformed graphically by a human. We can use some examples of raw form representation and discuss if it's efficient or not. Data may come in this form, like aggregated sales by cities, for example, or in this form, entry-level customer table. Here you see. And do you know what is this? What does this table represent? It's adjacency matrix, which is used for building graphs, graph networks. And you see how ugly it is in the table representation, right? We all know that it can be seen in a very pleasant way when we visualize it. And we saw the table examples, but we can also see data which is unstructured. Here you see an example of order records in JSON format, which is not very user-friendly. I think you would agree with me. Or even worse, look at this image. Do you recognize what is this? This is weblog history, and I think you agree with me that this representation is not very beautiful and is not very user-friendly and readable. But we saw that we saw some ugly examples of raw data in the previous section. We all know that people don't like this kind of representation of data and information. But do people visualize data? It's a very broad question. I don't have a statistic to answer this question. But what I think is that is what I have seen in my career until now. People, including me, use Microsoft Excel a lot, especially in financial sector. But what's wrong with Microsoft Excel? Nothing. Excel is the most universal software I have ever seen. Its code base consists of more than 30 million lines of code. 1.2 billion users have installed Excel on their devices, and 2/3 of them have ever used it. So it's huge numbers, right? But it's not the most flexible tool for visualization. And sometimes people become addicted to tools. They use the same tool for everything, but what happens when you not properly use it? This funny meme illustrates that situation when you don't use a proper tool for proper task. And I like really this meme. Many people tend to use default settings of visualization, which can cause this, or this pie chart shown here, which is result of bad visualization and bad default settings, or it can be this. I think all of you have seen such visualization. So let's come back to our big question. Why visualization matters? The answer is we live in the era of big data and we never have enough time, right? How are we going to make sense of all that information which is stored in big data platforms and flowing to us with different channels to make good decisions? Data visualization is an important answer to that. Data visualization uses visual data to communicate information in a manner that is universal, fast, and effective. In this way, process of understanding of information is much more scalable than reading the raw data. Let me tell you some facts related to the topic. 90% of the information transmitted to the brain is visual. The human brain can process an image in just 13 milliseconds. High quality infographics are 30 times more likely to be read than plain text. And one of my favorites, the last one, Wharton School of Business study found that the use of data visualizations could shorten business meetings by 24%, because sometimes business meetings are just waste of time, right? So visualization can help us with that. I think you agree with me that visualization is very important. We talked about the importance of data visualization and also mentioned bad visualization examples. If we agree that data visualization is important, then we have to visualize data and we should do it effectively. So the next question is how to make effective visualizations. I'm showing you popular examples of successful visualizations that might be familiar with you. For example, Iraq's Bloody Toll, which looks like this, or artists by variety of word usage shown here, or Washington Wizards shoots displayed here as an infographic, which is one of my favorites, and it's really attractive. I think you agree with me. The examples I showed you are inspirational, right? We also want to make such visualizations. Actually, it's possible, but before that, we need to know at least very basic things about visualization techniques. We need theoretical background and proper tools in our toolbox to do that. But my observation is that people invest most of their time in studying tools and not theory. Actually, none of the tools are perfect, but most of them are good enough to make effective visualization. Tools and their documentation change rapidly, but the theory is persistent, at least more persistent, right? So in my opinion, we should focus more on theory and less on practical implementations, because we are lack of that. To understand, to strengthen theoretical background of data visualization, let's discuss some components related to the topics, related to this topic. First of all, let's talk about visual perception, the concept of visual perception. How does it happen? Actually, there are three participants in this process: environment, which is creating stimuli with help of light; sensory organ, the eye, which is kind of middleware, and in the end, perceptual organ, the brain, right? Which is very unobserved and complex object. But we can say that there are three fundamental types of memory in the brain: iconic, short-term, and long-term memory. Iconic memory is similar to the graphics buffer of a computer. For it briefly stores what the eye see until it's either moved into short-term memory, also known as working memory, for conscious processing, or is discarded as non-essential. Short-term memory is like random access memory, like RAM. We all know RAM, right? In a computer. Readily accessible for high processing, but limited in capacity. Information that's deemed worthwhile for later use is moved from short-term memory into long-term memory, where it's stored and indexed in one or more ways for future retrieval, just like on a permanent storage device of your computer, for example, a hard disk. Understanding perception system is important for data visualization because we must consider that although it's powerful, working memory of human being is limited. And working memory is the one when actual sense making is happening in our brain. Let's show an example. Look at this figure. The figure exhibits a common problem in graph design. The meaning of the 9 separate data sets represented by the 9 different colored line can't be concurrently held in short-term memory. The readers are forced to shift attention back and forth between the legend and the line of data to remind themselves over and over what each line represents. If you want someone to make sense of the graph as a whole, then you must limit the number of data components that encode distinct meanings to 7 at most, and safer yet, to no more than 5. It's scientifically proved. On the other hand, we can use some tricks when doing visualization. Look at this example and try to find digit fives, and count them. And let me show another one. Now do the same thing here. Do you recognize how fast the second one was? In the first example, your brain used attentive process for the task. In the second example, brain used so-called pre-attentive process, which was way faster. The difference between two examples was simple. We bolded some digits in the second example, and this is called pre-attentive attributes, which is widely used in data visualization, and it's very efficient technique. Here, you see different examples of pre-attentive attributes. The effect and strength is not the same for different visual attributes. What do you think? Which pre-attentive attribute is the strongest? Actually, there is no one correct answer to this. As far as I'm concerned, the different forms, different attributes are used in different situations. It depends on the task and it depends on the data type, because some of them you cannot use, for example, on categorical data or on numeric ordered data, ordered categorical data. I mean, it depends on the data type and which information you want to encode. Let's move to the next section. This is very important, and I think many of you know this. Avoid clutter. This is a very important tip for data visualization practitioners. One of the early contributors of data visualization, Edward Tufte, or Tufte, I think Tufte is correct, introduced concept called data ink ratio. He was against cluttered graphs, and he stated, above all else, show the data. Data ink ratio is defined as data ink divided by total ink used in print graphics. Now we don't use graphics anymore. This is old theory. It was 1983. Sometimes we use ink, of course, but nowadays everything is in computers. So we can change this name and say pixel to data to pixel ratio. So the higher the ratio, the better the visualization. And it can be interpreted as also proportion of a graphic sync devoted to the non-redundant display of data information. And it's the same as 1 minus proportion of a graphic that can be erased. So it should be very high in order to have effective visualization. Here I can show an example of that. This is the original example of removing so-called chart junk from the graphic. On the left side, we see cluttered chart, and some elements on this chart is really extra and redundant. So I think you agree with me that the right one is better. If you search on the internet, there are many people against this theory because Edward Tufte was Edward Tufte's idea was minimalism, but it's not the only objective to maximize, right? When doing data visualization. Sometimes extra elements are also important, but for beginners, it's really good start point to remove clutter. It's always the case. People put much clutter in their chart if we see on the internet. We talked about clutter. Next one, which is very important thing you should consider, is to know what kind of graphs exist in the world, right? I will show some popular types of graphs for different kind of insights. These graphs are effective when visualizing some indicators or indicators changing over time. Especially line graph is very popular. Also bar and stacked bar. On stock market, you have seen candlestick, timeline, and so on. Area graphs are also very popular. Okay, the next one is in many applications, you will need to compare some categories to each other. In this case, bar graph, bubble graph, and the followings are good choice, a really good choice. Another common problem is showing ranking to rank different objects. If you show ordered bar in this case, it will effectively help you. Ordered bar is very effective visualization for ranking. Very popular, especially in financial sector, part to whole. These famous charts will help you in this case. I have to mention here that many visualization experts criticize pie charts and especially donut charts. The problem is that it's difficult to compare parts of circle precisely, but in some cases, these charts work really well. And especially top-level managers love them in financial sector. I'm saying from my experience. I'm saying for beginners especially. You may see in the internet, avoid pie charts, avoid donut charts, but I think you shouldn't consider that like that. I think in some cases, pie charts are really good. Depends on your audience and depends on your data. The next one, when doing statistical analysis, detection of relationship between variables is part of the problem. These graphs above all, scatter plot will help you in this case. And also bubble plot is really popular, and heat maps for categorical data. Again, in statistical analysis, understanding data distribution is crucial. For this, you can use histogram, box plot, violin, or density plots, which are quite oftenly used, and many libraries support them. And for the following two, flow and relationship visualization, they are less popular, but really beautiful graphs. Graphs are used here. For example, network graphs are various kinds and can be learned separately because it's a big topic. And it's really challenging to visualize networks efficiently, especially when you have lots of nodes and lots of edges. And in real world, we always have like that. Next topic is about basic elements of graphs. 21st century, right? We all Google things every day, and our knowledge is updated on daily basis. But I think you encountered the situation when you can't find the thing you are looking for on the internet. Why does it happen? There's everything on the internet. We can take everything. But the thing is that sometimes we can't efficiently search them. And sometimes the reason is that we search with incorrect keywords. So keywords are important. I think knowing the terms of visual elements of the graph will help anyone search for anything he or she wants related to the element. So my advice is know these terms. These are really important, especially for beginners. You can search everything if you know these terms. But I'm showing here on this visualization only one type of graph, which is taken from Excel. It's not the full list, so you should search it further on the internet. There are a lot more. The next tip for effective visualization is visual encoding. These are really important. When we create data visualization with this process, we encode information with visual elements and the user decodes it. This picture shows different kinds of visual encodings. One can encode information with position, color, shape, tilt, size, etc. It's not the full list. And each of them has different strengths and effect on visualization. And the relevance of visual encoding depends on the data type and the task itself. As we mentioned in the previous section, that it depends which kind of data you are working with. There is no one recipe for everything, right? The next one, which is big one, is color. Who loves colors in visualization? Color is perception. Our eyes see something, the sky, for example, and data sent from our eyes to our brains tells us it's a certain color, blue. Objects reflect light in different combinations of wavelengths, and our brain picks up on those wavelengths combinations and translates them into the phenomenon we call color. For example, I give you a little fact. People decide whether or not they like a product in just 90 seconds or less, and 90% of that decision is based solely on color. Imagine how important color is when you are building visualizations. So I think it's worth to spend some time for colors, because colors are mostly used incorrectly, and it's important to understand the basic elements of it. So let's start. The thing you are seeing on the slide is called color wheel. The first color wheel was designed by Sir Isaac Newton in 1666, and artists and designers still use it to develop color harmonies, mixing and palettes. The color wheel consists of 3 primary colors: red, yellow, and blue. 3 secondary colors created when primary colors are mixed: green, orange, and purple, and 6 tertiary colors made from primary and secondary colors, such as blue, green, or red, violet. So this thing is really important. This is base for color theory. Draw a line through the center of the wheel, and you'll get separate the warm colors, red, oranges, yellows, from cool colors, blues, greens, purples. Warm colors are generally associated with energy, brightness, and action, whereas cool colors are often identified with calm and peace. So it depends on your task and on your situation, which colors you want to use. But let's talk about the most important topic based on colors. Let's talk about color schemes and color harmony. It's not easy to choose colors when there are thousands of colors in our devices, right? And the number of their combinations are exponentially higher. But fortunately, we have color theory, which offers rules for getting harmonic colors. Harmonic colors are colors that goes well together. Based on the color wheel, there are 3 basic rules for color harmony. The first one is complementary colors. Here you see complementary color example. Complementary colors are opposites on the color wheel, red and green, for example. Because there's a sharp contrast between the 2 colors, they can really make imagery pop. But overusing them can get tiresome. Here you see a logo for Pepper Power. This logo is created with complementary colors. And it's really impressive, right? It's effective to use this kind of colors. but it depends for what you want to do that. The next one, the second one is analogous color scheme. Analogous colors sit next to one another on the color wheel, red, orange, and yellow, for example. When creating an analogous color scheme, one color will dominate, one will support, and one will ascend. And in business, analogous color scheme are not only pleasing to the eye, but kind of effectively instruct the consumer where and how to take actions. And the last one is triadic color scheme. Triadic colors are evenly spaced around the color wheel and tend to be very bright and dynamic. Burger King uses this color scheme quite successfully. And using a triadic color scheme in your marketing creates visual contrast and harmony simultaneously, and making each item stand out while making the overall image pop. The next thing about colors is HSL. And HSL stands for hue, saturation, and luminance. These are three different dimensions of each color. A hue is basically any color on the color wheel. When you are using a color wheel or a color picker, you can adjust the saturation and luminance of a hue. Saturation is the intensity or purity of the color, and luminance is the amount of brightness or light in a color. And here it's visualized in this picture. Let's move to the tips and tricks for using colors effectively. I'll share some of them with you. There are several tips you may consider. The first one is use saturation and brightness to make your hues work. Saturation and brightness are as important as hue. In fact, you can create new colors when you just change the saturation and brightness. Here on this picture, the right graph is better than the left one, isn't it? I think you would agree with me. The next tip is use warm colors with blue. There's a complementary color combination that is especially loved by data visualization designers: yellow, orange, red, and blue. Look at them. They are really beautiful together, aren't they? So it's well-tested color palette. The next one, the third tip I want to share with you is avoid pure colors. But what are pure colors? Pure colors. Pure hues are the ones that are located at exactly 16 degree, 60 degree, 120 degree, 180, and so on in the color wheel. You will see this kind of difference if you consider this tip. Here, the left one is not ideal, right? And the right one is really better. The fourth tip is avoid bright, saturated colors. Neon colors will definitely attract the attention of readers, but these readers won't thank you. Most of us get a bit stressed out when we see them. Highly saturated, light colors will not be appropriate for your visualizations. The next one is to avoid too little contrast to the background. A surprising number of charts on bright background use very pastelish colors. They are often not very saturated and awfully light. That comes with a problem. If you work with small areas like lines and dots, light and desaturated colors can be hard to distinguish for your readers. But even if legibility is not an issue, for example, bigger areas, your visualization should have enough visual contrast to the background to confidently communicate that, hey, I'm here and I have something to say to you. And here you see an example. The right one is traditionally better than left one because it has more contrast in it. And the final one, and one of my favorite, which is related to colors, it's the tip is called don't forget about color blindness. Approximately one in 12 men and 1 in 200 women in the world is colorblind. The most common form, but there are different kind of color blindness. The most common form of color blindness causes confusion between certain shades of red and green, though there are also forms of color blindness that cause blue and yellow shades to look the same. If you build graphs with colors which you think it's differentiable from one another, and your stakeholder is colorblind, then your whole work is under danger, because one of the main visual encoding, color, as we stated in the chat also, will be useless in that case. So be aware. So don't forget about that. Colorblind people, they are many. Next section is dashboards. Who loves dashboards? Everyone, right? Personally, I do, and many top-level managers do also. Here are some tips for building effective dashboards. They are my opinion, and I don't know if it's expert-level opinions, but in practice, I work with these tips. The first one is decide what your dashboard to do. Focus on your business problem. The second is only include what really matters and avoid scroll bars. I think dashboards with scroll bars is really bad idea. It can only be useful in very extreme situations, so avoid them. It's better. Users like when they see everything on a single page. The next one is keep important things on the top left part of the dashboard. By using modern eye tracking technologies, we can see that users start reading from top to bottom and from left to right. And it's really important. It's important because real estate of visual dashboard is limited, and we have to lay them out properly in order to attract users' attention to the most important pieces. Use friendly labels and keep things clean. Often dashboards contain a lot of information and interactivity, and for user, it's not hard to understand how things work. So try to build clean charts, clean graphs, and visualizations. Remember the Tufte principle, data ink ratio, and use friendly labels for readability. The last one is display timestamp. It's weird, right? It's a very small piece of dashboard, but very practical. I think so. Dashboards are usually interactive and continuously updating, right? Sometimes users take screenshot for evidence of some facts. If report date timestamp is not included in the screen, it makes screenshot useless because we don't know when was the screenshot taken, right? So display timestamp, it's easy. And finally, I want to talk about the next section, which is tools. Tools for data visualization. We criticized a lot in the beginning, right? We criticized using tools not properly, but if you are equipped with right tool for right task, it's really powerful. And after all, tools are essential part of our work. Choosing proper tool will increases our productivity significantly. Nowadays, there are a lot of tools for making data visualizations, as you may already seen. And I will focus on the ones that are related to Python, as it's mentioned in the description of this talk. The problem is that Python has many tools for visualization. Here you see visualization of Python's visualization landscape. This plot is created by Jake Vanderplas. This guy is important contributor of Python open source community, such as SciPy, scikit-learn, and many more. He created this plot for PyData conference, and I like it very much because you can see big picture of landscape. Here you see different clusters with different colors. Big cluster is based on matplotlib, as you all may know. Another is JavaScript based libraries, and etc. So I really like this landscape example, but let's move in to the next one, which I also like very much. I like this diagram, which I took from Practical Business Python. Here is a flow, how to choose the correct tool. We start from here and we ask ourselves, we like ggplot2 syntax or not? And if yes, we choose plot9. And if you want to try something new, we try altair, and the altair is also created, I think, by Jake Wanderplas, which I mentioned before. Then we can ask the question, we want to customize or unique plot. If yes, we have to choose matplotlib. And if we want quick plot, as you mentioned in chat, we should go to pandas. And if we want some interactivity, we have to go here and we have to flip a coin. And if it's heads, we choose Bokeh. And if it's tails, we choose dash. And dash is based on plotly. I like this visualization. I like this diagram, and it looks practical. And finally, I made a diagram which is cheat sheet for me personally, and I want to share it with you. Let's see what's happening here. This is my diagram. This is my experience. We start from here, and the first question is, do we have more than enough time? And if we have more than enough time, which I think we never have more than enough time, but if we have to choose D3.js. D3.js is, I think, most customizable library and the best library for data visualization. But it really has steep learning curve, and it's really hard to build even basic charts in D3.js, and you have to know JavaScript for that. So if we live in the real world and if we don't have enough time, more than enough time, then we have to ask, do we know Python? Are we Pythonista? If no, I don't have an answer to that. You should ask someone else. But if you are Pythonista, the next question is, you want quick exploratory analysis or not? If yes, the matplotlib integrated in pandas is the best option. With my experience, I can say that. But if you want some interactivity, matplotlib doesn't support that. And sometimes interactivity is essential. And if you want interactive plot, it depends on which kind of plot you want to make. If you want single or couple of plots, standalone document, you should use Bokeh. But if you want dashboard, things laid out correctly and serving over time, the next question is if you have license of Power BI. If you have Power BI, then you should use that because it's a great tool and its market share is increasing in last years, and it's really practical, especially in enterprise environment. But if not, and if you are open source guy, and if you don't have license, and you like open source Python libraries, you should go to Bokeh again. And actually, my favorite one is Bokeh. So in this section, we will talk about Bokeh. Bokeh is, personally for me, it's the best visualization library in Python because it gives us interactivity. Bokeh is an interactive visualization library for modern web browsers. It provides elegant, concise construction of versatile graphics and affords high-performance interactivity over large or streaming datasets. Bokeh can help anyone who would like to quickly and easily make interactive plots, dashboards, and data applications. Bokeh is quite big library, and it's based on both Python and also on JavaScript because it's executed, some of its parts is executed in browser. Here you see the examples of Bokeh, and let me show some examples which is built in Bokeh just as images. Here is, for example, Texas unemployment choropleth. This plot is called choropleth, as you all know. We can build such graphs in Bokeh, or like this, unemployment also built in Bokeh for different years and for different months. And also some example from biochemistry. This chart is really highly customized, as you might have already noticed. And we can also build this in Bokeh. And some of you may know this example. This, I think, is from astrophysics. And this is also customized graph, and you can build in Bokeh. Or beautiful graphs like this, which shows different distributions for different categories. And everything this is interactive. And also you can build interactive dashboards like this. I'm showing in the format of GIF. This is famous Gapminder example by Hans Rosling, as you might already know. It's very inspirational graphic, which was created by Hans Rosling, and it's dynamic because it's changing over time, and it's just scatter plot which is given for each year and each month. And this implementation I'm showing you is built in Bokeh. So in order to build basic visualization in Bokeh, it's very, very simple. I'll show you the example like this with image. This is basic line chart, and the syntax here is we just import some two main components of Bokeh. This is high-level component, which is called plotting, and the low-level component, which is called models, and some extra components for I/O, layouts, and palettes. And here you see we just define two lists in Python, just regular lists as X and Y. We provide it as an argument for the figure, which has the method line, because line is a glyph for the figure, and it needs coordinates X and Y, and it just plots it. It's very easy.